Today we're going to apply what we've been learning to some triangles with kind of real world applications. There's just two terms we need to know, they're on the screen: angle of elevation and angle of depression. So I would always use the angle of elevation. I'll show you what they look like, and I'll be saying it a lot, but they are the same value, and elevation is just easier to not get wrong. So let's say we've got a cliff like this, and maybe there's like a lighthouse at the top, and it's going to spam a light going. And we need to, sorry, forgot half the drawing. There's a boat down the bottom as well. Now, we can work out distances if, say, we know how tall the cliff is and the angle down to the boat. We can work out, how far away the boat is using our right-angled trig, which is pretty handy in some situations. What we're going to be using is the angle of elevation, angle of depression. Now, they are always in between what we call the line of sight. Let's see if I can write neatly enough here. I might write it this way. They are always between the line of sight and the horizontal. So angle of elevation is pretty easy. It's in between the horizontal, usually the ground or the water, and the line of sight. But the angle of depression is a bit harder. It's really tempting to think it means here, but that is between the line of sight and the vertical. Now the horizontal is across here, and so angle of depression is here. Now those are the same angle, because this is parallel to this, and that leaves me with alternate angles, and alternate angles are equal. So we need to remember that, and it's going to save us a lot of hassle. Anytime we see angle of depression mentioned in a question, we can just use the angle of elevation or find the angle of elevation and write the same answer, because they are always equal, they are always alternate angles. Alright, so let's write that down. So the angle of elevation is always equal to the angle of depression. Let me just move it before I keep going. They are between the line of sight and the horizontal. Remember, horizontal. The most common mistake is going to be putting the angle here when that's not the case. So we can use these in a problem. Why don't we do a problem with a lighthouse and a boat, or maybe just a cliff and a boat, so there's less drawing to do. So we've got a cliff. I'll have a boat. Hopefully you can draw better than me. Someone's at the top looking down to the boat. So the question might say, oops, I meant to be E dot G dot. E.g., let's say the person is standing on top of a 40-meter cliff and sees a boat at an angle of depression of, let's say, 23 degrees. How far away is the boat from the bottom of the cliff? So when it says how far away from the bottom of the cliff, that means we're not finding that distance, we're finding from the bottom of the cliff to the boat. So we're finding this side here. Often in these questions, this is a line of sight. We don't really measure that all that often. Sometimes it might be a supporting cable or something like that, and we'll be finding it. But more often than not, we're going to be using tan, because we'll have a vertical and a horizontal, or an opposite and adjacent. Alright, so I'll keep it here, we should have room. I draw in my line of sight. It says angle of depression of 23 degrees. Now I've said always use angle of elevation, so I'm going to put the 23 degrees here, and I know the cliff is 40 meters high, so I'm going to redraw this without all the frills, just a right angled triangle, 23, 40, and now it's pretty simple. Oh, and one other thing, we're trying to find this one, so we'll call that the unknown x. So label the triangle, hypotenuse, adjacent, it's next to the 23. 40 is opposite. Well, we want this one, we know this one, so O and A mean I'm using tan. So tan, 23 degrees equals opposite over adjacent, 40 over x. Now x is on the bottom, so I know it's going to come over to this side on the top, and this is going to come over to this side on the bottom. 40 over tan. We were much better at that today. I mean, yesterday by the time you're watching this. So, well done with that. So x equals, and then we type. I don't have my calculator up on my screen, but I do have my one here. 40 divided by tan, 23. Equals 94.2 meters to one decimal place. There you go. Alright, a lot of the questions aren't that different from that. What I really recommend is trying to figure out what the triangle actually looks like. Because once we're here, we've done this now quite a bit. Try and figure out what the triangle looks like. Always use angle of elevation, and you'll be much better off. I'll let you get to the class kick and have a go.